We're going to look at buffer capacity. Before I do that, I just wanted to show you if you do get a problem, a buffer problem, and they give you a PKB instead of a PKA, or a KB instead of a KA, then all you need to do is convert that to PKA. Okay, so here it says use the Henderson-Hasselbalch equation to calculate the pH of a buffer. So remember, you have to use the Henderson-Hasselbalch equation. And in that equation, it says pH equals to pKa plus log of your base over your acid. So you need pKa. So if they give you, in the problem, you see 0.5 molar of NH3 to 0.2 molar of NH4Cl, pKb is 4.75. See, they give you pKb, you need to convert that to pKa. Remember the equation, pKa plus pKb equals 14. So literally all you do is you get your pKb, and you subtract that from 14, and that'll give you pKa, okay? But everything else you do exactly the same. You put your base of your acid, you do all of that. The only small step you might need to do is just convert your pKb to pKa using this equation right here. Okay, so let's look at buffer capacity. So we're just going to look at a little vocabulary here. So buffer capacity is basically, at this point, how much acid or base can it effectively neutralize. So this is the amount. So this would be like you're either looking at moles or molarity. So how much can it neutralize? So remember, we have our beaker, we have our weak acid or weak base, and we calculate the problems where you put a strong acid or a strong base in there. And so the capacity is basically how much strong acid or a strong base can we add in there before the buffer is destroyed. And how do we know it's destroyed? Well, you'll have a dramatic change in the pH. And so remember, when we're calculating them, the pH doesn't change by not much, maybe a tenth of a number, okay? But if all of a sudden it increases or decreases dramatically, by like 4, then you've destroyed the buffer. You'll see, there'll be a huge change in the pH, okay? The buffer range is different. This is the pH range over which it can effectively neutralize, okay? So this we're looking at an actual pH. This we're looking at the amount, okay? Again, pH equals to pKa, so whenever the buffer is the most effective when you have equal amounts of acid and base in there, all right? So those are just some vocabulary I want you to know. So buffer capacity is the amount it can neutralize, okay? And if we go back over here, the buffer range is the pH range it effectively neutralizes.